Hey everyone! Thanks for joining us for another Stonehearth Desktop Tuesday. This is the bustling metropolis of Konistrapolis by Stonehearth player Kythandra, last seen during Stream 200. Our team absolutely loves seeing fabulous saves like this. They inspire us to make the very best game we can, so that you can keep making and showing us all amazing things just like this. Aside from being inspirational, saves like Konistrapolis are also motivational. They show us where the game falls down and where we could make it better. For example, in a large town like this, we often see that the game begins to stutter and slow down. In extreme cases, on older machines, loading a save of this complexity can even cause your game to crash to the desktop. Today, let's take a look at why this is, and what we as a team are doing to mitigate the problem. In a simulation game like Stonehearth, everything you see in the world, logs, trees, terrain, buildings, windows, furniture, people, everything, has data associated with it. What model it uses, how big it should be when it's rendered, where Hearthlings should stand when they're interacting with something, etc. When you play the game, this data is stored in the memory or RAM of your computer. If you have a lot of things in your game and the game's memory usage begins to approach the total amount of RAM on your computer, or the amount of memory that Windows has allowed Stonehearth to be able to use, the game begins to stutter and lag because it becomes harder and harder for the game to find the relevant data that it needs to draw the simulation to the screen. If the amount of memory used by the game ever exceeds the amount set aside by your computer for it, the game will crash to the desktop. Preventing these crashes is one of the reasons that we implemented inventory caps a few alphas ago. If you leave Stonehearth running and then come back 3 hours later, for example, your farmers won't have accidentally crashed your computer by creating 300,000 pumpkin baskets. But the inventory caps were a stopgap measure that we mean to revisit. A much harder, but arguably better way to solve the problem is to go through the code with a fine-tooth comb, looking for ways to reduce each item's memory footprint. This is what Yang has been doing for the past few weeks. This is Yang's memory test world. Wooden logs are some of Stonehearth's most basic and plentiful items, and they use the same data structures as many of the more complex items in the game. So in this test, Yang has been spawning 10,000 logs, recording how much memory they use, and then making changes to the code to reduce the amount of data we store for them, and then running the test again to see how much the footprint has decreased. For example, if you've got debug tools, you can see that each log maintains its information in structures we call components. Components are very flexible. They allow us to manipulate the data on an object and make that object behave according to the simulations of the game, physics, usage, crafting, etc. Yang has been slowly going through and pruning out unnecessary components. For example, the unit info component used to let you store and change an item's name, portrait, and description. This is important for people and pets and monsters whose names and portraits might change. This information, however, never changes for objects like logs, so for all objects like them, she's removed their unit info component and is instead storing this data in a much more efficient, read-only structure called entity data. She's made similar optimizations to other components that used to be on things, but that, after her changes, are only on the few items that really need them. For example, items used to have a material component, but in Stonehearth today, an item's material never changes, so this too can move to memory-efficient read-only data. The model variant component, which stores the appearance of an object, is now stored just once for all objects of a type, and the render info component, which listens on model changes, only does this for models that actually do change, like berry bushes. The destination and adjacency regions for interactable objects like trees and workshops also almost never changes, so this data too is now read-only, and the full component only continues to exist on things like buildings and stockpiles, where the place a hearthling should stand relative to it is always changing based on the state of the building. Yang has made more complex optimizations too. She's turned all the booleans on a mob component, which tracks the placement for all objects in the world, into bits, so that they take up less space, and she's made it so that navgrids, the objects that make up the terrain of the world, only store speed-modifying data whenever it's needed, instead of all the time. As you can imagine, these sorts of changes are like performing live surgery, carefully, painstakingly changing the way the code works without changing its function or introducing new bugs. But in the end, it's well worth it. Yang's log test yielded an impressive 20% improvement, for example, in the memory footprint of static objects, and a whopping 50% improvement in navgrid tile memory usage. Overall, we think the total memory improvements across all elements of the game is thus far about 10%, which means a total 10% increase in the number of things you can amass before your game starts to slow down. Yang being Yang, of course, is completely unsatisfied with her work thus far, and will soon turn her attention to even more complex areas like building. I keep hoping to find the golden goose, she tells me, but in the meantime I will keep selling the regular eggs. And that's all the Alpha 18 performance improvements I have to talk about this week. Let us know your thoughts in the comments or on our forum at discourse.stonehearth.net. Find other Desktop Tuesdays on stonehearth.net and join us for our weekly streams on Tuesday at 6 p.m. PST, Wednesday at 8:30 a.m. PST, and Thursday at 6 p.m. PST. We love hearing from you, and see you next week.